Our next few videos are going to look at advanced thermal treatment, which is the term I'm using to describe pyrolysis and gasification together. So just for an overview of how they differ from incineration, which burns the waste directly, pyrolysis and gasification focus on transforming the waste from its solid state into a mixture of solids, liquids, and gas for pyrolysis, or just gas for gasification. And then those can be used for making materials or used for energy later on. But the pyrolysis or gasification process itself is really about transforming the molecular structure of that waste into something that's more easy to use for something else. Now, the gas that comes from pyrolysis and gasification, or the oil, could be burned for energy, which is just a little bit more of an efficient way to do it than trying to burn the solids more directly as are done in the mass burn incineration. They could be cleaned up and used elsewhere as an alternative fuel, or they could be used as a feedstock to make other molecules for fuels or materials. We're kind of breaking down the waste into its building blocks, and you can do something else with those. The distinction between pyrolysis and gasification, again, is pyrolysis. There's ideally no oxygen at all. We talked about it's an endothermic process. We're really just cooking the waste. Whereas gasification, we just introduced a little bit of oxygen below the stoichiometric requirement, and that helps the reaction to feed itself, as well as helps to push our solid and liquid products all into forming gaseous products. So we have one more homogeneous mixture to deal with, rather than pyrolysis, which gives us solids, liquids, and gases. So even though I'm calling these advanced thermal treatment technologies, pyrolysis and gasification are really not new technologies at all. For example, pyrolysis is used for creating charcoal, which has been done forever, as well as gasification has been used since the 19th century, at least for producing gas from wood and coal. And that allowed things like coal gas street lighting, and wood gas was really widely used during wars where there was a shortage on fuel. You would gasify the wood and use that to power your things that were normally powered by gasoline, such as cars. And there's a really interesting video that I've shared here. There's a YouTuber, Colin Furs, who's like a maker and makes all these weird inventions. And he's modified a lawnmower to run on wood gas. And it's kind of interesting to see how he puts it together and some of the operational considerations that he needed to take into account to run on wood gas. And you can really see how the three products of pyrolysis come out in there. You'll see there all this tar, which is the liquidy oil product sticking up the machine, as well as the flammable gas, which you can see in the picture, and then the char left over and ash from the solids. So pretty interesting video, which will give you like a really good sense of how you'd actually do this at a small scale. So something that has been around for a long time and you can do in your garage if you really wanted to. In terms of what bigger municipal solid waste plants, there's pretty limited uptake of pyrolysis and gasification in Europe and North America. There's more uptake in Japan. They're a little more forward in the technology, and they also have less space because they're an island and they're full of mountains. So they're more invested in these technologies, which can make their waste smaller and more manageable. But perhaps we'll see more growth in North American and European markets in the coming years. Recently, there's been renewed interest in pyrolysis and gasification because of all these issues of waste that can't be diverted yet into other streams, and what can you do better with this waste than incinerating it or landfilling it. So this potential of pyrolysis and gasification to kind of recover the materials and use them for making new materials or use them for alternative fuels, which can be used offsite, is one of the attractive reasons why these technologies are having some renewed interest. If you start Googling around, you'll find many failed pyrolysis and gasification projects, which is why they were classed as higher risk in one of the evaluation matrices I showed you before. So there's not a whole lot of these around, and some of them that have been tried have failed in different ways. So one of the risks with new technologies, but there's some interesting things about these technologies which are worth learning about and looking into, which we'll do.